Hi dear students, how are you? After long days I getting a chance to see you. Very nice to see you dear students. I am Selvarasu, your physics teacher. I hope all are fit and fine in your home. Dear students, we know that due to the corona pandemic, the whole country has locked in itself. The country is struggling with schools, teachers and lack of education. Most of the schools of the country have started online classes. Dear students, you must take advantage of this opportunity. Our school management also started this channel for giving the online classes to continue your study. It is easy to make the connection with you all, and it will help us to cover the syllabus and to maintain the flow of study. This connection is not limited to the class, but this session will be available for all. And I recommend you take the practice, especially in physics, formulae, definitions, explanations, diagrams and other facts. I will love to see your individual talents and strengths. Dear students, if you have any query, you can ask in the WhatsApp group. I welcome you all to join in the online classes. I hope to see you soon in class. Stay home, stay safe. Dear students, in our previous classes, 10th standard physics, we have discussed a number of topics, especially force, mechanics, kinematics, kinetics, statics and other things also. Newton's what is that first law of motion? After that what is that momentum, moment, all these things we have discussed. In this session we are going to discuss about Newton's second law of motion. So already I have studied what is the Newton first law of motion, isn't it? Yes or no? So in this session, so what we are going to discuss? We are going to discuss about Newton second law of motion. Okay, what is the name of the topic? Newton second law of motion. So what is the Newton's second law of motion saying? The rate of change of momentum is directly proportional to the applied unbalanced force. The rate of change of momentum is directly proportional to applied unbalanced force. Or otherwise we can say like this. The force acting on a body is directly proportional to the, what is that? Rate of change of momentum. Okay, what is that? Second law of motion saying? Rate of change of momentum is directly proportional to applied unbalanced force. The force acting on your body is directly proportional to the, what is that? Rate of change of momentum. Rate of change of momentum. This is the second law of motion saying. So already you have studied what is the momentum and which symbol denotes the momentum also. The symbol P denotes the momentum. Is that a yes or no? The product of mass and velocity. That is said to be momentum. Okay. So impact of which means what is that force? If you want to measure the impact of what is that force, we need one physical quantity. That quantity only we are saying what is that momentum. Is that a yes or no? So here what is that? We are going to what is that? Prove second law of motion through what is that? One explanations. Okay. So let us consider mass of an object m. Okay, let us consider one object. This is the one object. Of mass, what is the mass of an object? Small m. It is moving with the initial velocity. It start moving the initial velocity u moves in a straight line. Okay. After the time interval t, the velocity of the object changes to what is that? V. But there is no change in the mass. Okay, there is no change in the mass, but velocity is changing. Initially, while the object starts to move, the velocity of an object u, that is we said to be initial velocity. And so what is that? After time interval t, what is that? The velocity of an object changes to v, that is we said to be what is that? Final velocity, isn't it? There is no change in the mass, isn't it? Yes or no? So now we are going to now what is that? Prove the Newton's second law of motion. Okay. So here if you want to be proof, what should we first find out? We should find out the initial momentum of an object and then final momentum of an object. Okay. So now what is that? The first one is initial momentum of your body, initial momentum of the body or object. Okay. So that is which symbol denotes the momentum? The symbol P denotes the momentum, suffix I. Why? Because this is the initial momentum. Okay. So what is the momentum? Already told you. The product of what is that? Mass and velocity. Okay. So here what is that? Initial mass? No, when the object initial mass of an object, there is no change in the mass. So that is we said to be alright m. But velocity here, there is what is that? There is no change in the mass, but changes in the velocity. So initially the velocity of an object u and the final velocity of an object v. So that's why what is the initial? So what we are doing here? So we are finding out the initial momentum of an object. So that's why we should apply here initial velocity of an object u. Okay. So this is the initial momentum of a body or object. Okay. Now what is the next? Our second aim. So we should find out the final momentum of a body. What is that? Final momentum of a body, that is P suffix F will come. So this is equal to, there is no change in the mass, we can write similarly m. And what about the velocity? Final velocity v should come. Okay. And next our aim is we should find out the change in momentum. What is that? Change in momentum. Change in momentum. So whenever we are using the word change, which symbol denotes or represents the change, the symbol del represents the change, and change in momentum means del p. What is the meaning of del p? Del p equal to change in momentum. So del p equal to, so how should we convert, what is that, find out the change in momentum? We should subtract from the final momentum of your body to initial momentum of the body. So what is it, which symbol here? Final momentum of the body, the symbol pf. We should subtract from p suffix f minus p suffix, what is that? I should come. Okay. So next our aim, change in momentum. Again one more time I will write here del p equal to, what is that? P suffix f minus p suffix I should come here. Okay. So we should apply the value here. So already we found that values for pf and then pi. Take that values, substitute within the formula. So let us see what we'll get. Okay. So here the value of what is that? Pf mv, and the value of p suffix I, what is that? mu will come. So here we should consider, so we should see here which one is the common here. The m is common, so that's why take out. Okay. So m of v minus u. So what is this? This is the change in momentum. Okay. What is that? Del p equal to change in momentum, m of v minus u should come. Okay. So next our aim is to find out rate of change of momentum. What is our next aim? Rate of change of momentum. Okay. So how to find out rate of change of momentum? Already we have found change in momentum, that is m of v minus u. So now whenever we are using the word rate, which means time, isn't it? Yes or no? Our rate of change of momentum means f of v minus u divided by t. So this is the rate means time, rate of change of momentum. M of v minus u divided by nothing but m of v minus u is nothing but this is the change in momentum. T is nothing but t. So that's why we are saying a rate of change of momentum. Okay. So now our next aim is, what is that? We have to be prove the second law of motion. What is that? Second law of motion. How to prove second law of motion? So by using the second law of motion, what is the second law of motion saying? In what is that? Initially in the previous already told you, what is that? The force, what is that, acting on your body is directly proportional to the rate of change of momentum, or otherwise how can we give some other explanation for it? The rate of change of momentum is directly proportional to the applied unbalanced force. Okay, so F is directly proportional to the rate of change of momentum. Okay, what is that? Rate of change of momentum. Okay, so now F is directly proportional to rate of change of momentum, which means already what is that? Rate of change of momentum found here. Take this, what is that formula? Substitute here. M of v minus u divided by t should come. Okay, now F is directly proportional to M, you should write here, v minus u divided by t. These things we should what is that, consider here. So already what is that, we know that acceleration, definition for acceleration. What is the acceleration? Rate of change of velocity. Isn't it, yes or no? So acceleration A equal to rate of change of velocity, which means final velocity minus initial velocity divided by t. So this is v minus u divided by t. This is equivalent to acceleration. So that's why what will we do? So instead of these things, we can substitute A. Isn't it, yes or no? A is equivalent to this. So that's why F is directly proportional to MA should come. Okay. So now one thing you should keep it in your mind. Okay. So what directly proportionality is there. So if you want to be remove, what should we do here? We should add one constant. Okay. So which is a sufficient constant here? K is a sufficient. Okay. So F equal to K M A. So what is the K here? Proportionality constant. Okay. So here we should give the one value for K. So therefore the value of K equal to 1 should come here. Okay. So F equal to 1 into MA will come. So F equal to MA. So this is the, what is that? Second law of motion formula. Okay. So F equal to MA. Isn't it, yes or no? Now one thing you should keep in mind. F equal to MA. So this is second law of motion. So what is that? Second law of motion is help us to find out or measure the force. Okay. So that's why we can say Newton's second law of motion is also known as, what is that? Law of force. Okay. So this is the, what is that? Explanation or proof about the Newton's second law of motion. Okay, already what we have proved? Newton's second law of motion. So according to the Newton's second law of motion, what is the final formula? F equal to MA. What is that? Newton's second law of motion help us to, what is that? Find out the force. So that's why we are saying Newton's second law of motion is also known as law of force. Okay. So now we are going to discuss units of force. The SI units of force is Newton. SI unit of force is Newton, and in CGS unit, what is that? CGS units, what can you write here? Dyne. What is that? Dyne. So this is Newton. Okay. So next we are going to discuss, what is that? 1 Newton. What is that? 1 Newton. So already we know that F equal to MA. The unit of force is Newton. The unit of mass is kilogram. Into the unit of acceleration is meter second power minus 2 should come. Suppose if we consider the unit of force, now what is that? The quantity of force is 1 Newton means what will we get here? 1 kilogram, 1 meter second power minus 2. Okay. So here what is that? Based on these units, easily we can give the definition for 1 unit. So what is the 1 unit? 1 unit is nothing but nothing but students, the quantity of force required for the mass of an object 1 kilogram produces an acceleration 1 meter second power minus 2. Then the force is said to be 1 Newton. Let us consider this is one object of mass 1 kilogram. Okay, mass 1 kilogram. So if you want to move this object, what should we do? We should apply the some amount of force. So the force is required for an object 1 kilogram, for an object of mass 1 kilogram produces an acceleration 1 meter second power minus 2. So what is the mass of an object? 1 kilogram. If you want to produce an acceleration 1 meter second power minus 2, or if you want to make the acceleration object 1 meter second power minus 2, what should we do? We should apply the force. What is the quantity of force? That is said to be 1 Newton. Can you understand, dear students? Okay, so this is 1 Newton. Next we are going to discuss what is the definition of 1 dyne. So this is the definition of 1 Newton. So now we are going to discuss definition of 1 dyne. So 1 dyne equal to 1 gram into 1 centimeter second power minus 2 should come. Okay. So here, how to give the definition for 1 dyne? So same way, similarly, how did we give the definition for 1 Newton? Similarly, we can easily give the definition for 1 dyne. So some changes, little bit changes is there. So what is the change? Instead of using the 1 kilogram, we should use the 1 gram. Instead of using the 1 meter, here we should use the 1 centimeter. This is the difference between Newton and dyne. Okay. So how can we give the definition here? See, let us consider one object of mass 1 gram and acceleration 1 centimeter second power minus 2. So the amount of force required for an object, for mass of an object 1 gram produces an acceleration 1 centimeter second power minus 2. Then the what is that? The force, the amount of force is said to be what is that? 1 dyne. So this is what 1 Newton. Okay. So this is a definition for 1 dyne. Can you understand, dear students? So here 1 Newton equal to how many dyne? Suppose in case sometimes they may ask a question in 1 mark. So how to give the answer for that question? So 1 already we know that 1 Newton equal to 1 kilogram into 1 meter second power minus 2. 1 dyne equal to 1 gram into 1 centimeter second power minus 2. 1 Newton equal to how many dyne? If they ask, how can you give the answer for this? So 1 Newton equal to 1 kilogram equal to how many grams? So we can, what is it? So right here, so 1000 grams equal to 1 kilogram. So 1000 into, so 100 centimeter equal to 1, what is that, 1 meter. So 100, what is that, centimeter. So here, centimeter second power minus 2. Here what should come here? So 1 kilogram here, this is a 1000 gram into 100 centimeter second power minus 2. So now 1 Newton equal to, if you multiple these values, what will we get here? So what is that? 1 lakh will come. Okay, what's how much? 1 lakh into, so what is that? Or otherwise write down unit, gram centimeter second power minus 2 will come. Okay. So next 1 Newton equal to, so how can we write? So here we should simplify. Alright, we can shortly 10 to the power of, how many zeros are there? 5. So 10 to the power of 5. We can write like this. Okay, 10 to the power of 5 gram centimeter second power minus 2 will come. Okay. So already we know that 1 Newton equal to, see, 1 dyne equal to 1 gram into 1 gram into 1 centimeter second power minus 2. So here 10 to the power of 5 gram centimeter second power minus 2 is there. So instead of gram centimeter second power minus 2, we can, what is that? Right here, dyne. Isn't it? Yes or no? So 10 to the power of 5, 10 to the power of 5 dyne. 1 Newton equal to 10 to the power of 5 dyne. Okay, dear students. So next we are going to discuss about unit force. What is that? Unit force. Unit force is nothing but, dear students, already we have discussed 1 Newton. Same way, which means similarly, we can give the definition for unit force. Okay. The amount of force required to produce an acceleration 1 meter second power minus 2 for mass of an object 1 kilogram. That is said to be unit of force. So let us consider the similarly. This is one object of mass 1 kilogram. The amount of force required for produce an acceleration 1 meter second power minus 2 for an object 1 kilogram, that is said to be unit of force. Can you understand, dear students? Next we are going to discuss unit of gravitational force. Okay, in SI system, units of gravitational force, what is that? Kilogram force. So 1 kilogram force in SI system, how can we write? So what is that? 1 kilogram force equal to 1 kilogram into 9.8 meter second power minus 2 should come here. So if you multiply these values, what will be getting here? 9.8 only. So kilogram meter second power minus 2, that is equal to what is that? Newton, 9.8 Newton. We can write like this. Okay. Suppose 1 gram force equal to, what is that? 1 gram into this equivalent value, what is that? 980 centimeter second power minus 2. So that is equivalent to, what is that? 980, which means 980 into 1, what will be getting here? 980. And then this gram centimeter second power minus 2, this is equal to dyne. So these are units of, what is that? Units of gravitational force. Okay. So next we are going to discuss about the topic name is impulse. What is that? Impulse. Impulse is nothing but, dear students, the larger force, the large force acting very short time, that is said to be impulse. Okay, the large force acting for very short time, that is said to be impulse. Okay, so which symbol denotes the impulse? The symbol J denotes the impulse. Okay, so let us consider what is that? The force acting on your body F for a short time T means, so the product of force and time, that is said to be impulse. Okay, the product of force and time. So let us consider one object. So what is that? The quantity of force, the amount of force acting on your body F. So what is that? It is acting for a short time, that is said to be, what is the time? T. So what will be getting here? The product of force and time, that is said to be impulse. Which symbol denotes the impulse? J. So J equal to, what is that? The product of force into time. Okay. Suppose this is, let us consider or said to be equation number 1. So if using the Newton's second law of motion, Newton's second law of motion, according to the Newton's second law of motion, F equal to rate of change of momentum. So already told you which symbol denotes the change in momentum? Del P. So del P divided by T. T means nothing but rate. Rate of change of momentum is directly proportional to applied unbalanced force. So here, so if you want del P means what should be here? So rate change in momentum equal to force into time will come. So let us consider this is the equation number 2. This is the equation number 1. Okay. So now what should we do? So from equation number 1 and 2, from equation number equation number 1 and 2. So what is that? J. So here see the impulse J equal to force into time, and the change in momentum del P equal to force into time. So this is common. So now we can write J equal to del P. J equal to del P. So these equation indicate for us what is that? J is nothing but impulse, del P is nothing but change in momentum. So impulse is also equal to the change in momentum. Impulse is also equal to the change in momentum. Okay. So now we can see some examples related for impulse. So what is that? So while we are traveling in the automobiles, If you observe the automobiles are fitted with a spring. What is that? Spring and shock absorbers. Why? Because of while we are traveling by the automobiles in the uneven roads, what's happening? So definitely we can now automobiles undergoes by the sudden jerk. So if you want to be escape from that, what is that spring and shock absorbers reduce to that jerk, which means shaking. What is that from that uneven road? Okay, and the next one is what is that? So in cricket game, the fielder just pulls his hands back, not downward directions. Why? Because of to reduce the impact of force. While is what is that? Pulls his hands backside. What is on a downward direction? What's happening there? Is increasing the time. While is increasing the time, the impact of force will be reduced. Impact of force will be reduced, which means impulse will be reduced. So that's why you can experience very less impulse. Very less impulse. These are the examples for impulse. Okay. Next we are going to discuss about the topic name is Newton's third law of motion. Newton's third law of motion. What is the Newton's third law of motion? For every action there is equal and opposite reaction. For every action there is an equal and opposite reaction. Let us consider one object A and another object B. The object A acts on object B Fa force, and at the same time, what is that? The object B exert the same amount of force, which means F suffix B force on A. So while the object A exert the force Fa on B, at the same time the object B exert Fb force on A. Okay. So here the action we said to be what is that? Fb. This is we said to be action, which is equal to Fb is reaction. Okay. So let us consider this is the wall. What is this? Wall. So if one man is standing here, while he is throw any ball. Okay, ball. Make it what is that? Strikes or hits on the wall. What's happening again? What is that? After this ball hits on the wall, again rebounds towards this man. Rebounds. So the ball hit on the wall. That is said to be action, and the ball exert some force on this ball and make it rebounds. That is said to be reaction. The ball, if it is hits on the wall, that is action. Again, the ball bouncing back, that is a reaction. Why the ball is bouncing back here? The ball exerts amount of force. Okay. So this is the what is that? We are saying Newton's third law of motion. So Newton's, which means what is that? Always this force acting on the two different bodies. That is not a same bodies. I can give some other examples for Newton's third law of motion. So if the birds are flies in the sky, what's happening? The birds, it's what is that? Feathers, wings. So it is pushing downwards. Okay, so that is we said to be action. While the birds, what is that? Its wings pushing downwards, action. At the same time, the air just what is that? Pushes its birds upwards. That is we said to be reactions. What is that? The bird, its wings pushing downwards, action. At the same time, air pushes its birds upwards. That is reaction. Swimmer. Another example is swimmer. The swimmer while he is swimming in the water, what's happening? He is moving or pushes his hands backward directions. Why? For moving forward. So that is we said to be action. While the swimmer is what is that? Pushing his hands backward, that is action. At the same time, water pushes him forward, that is said to be reaction. Okay, so these are the examples about the Newton's third law of motion. Okay, dear students. So next we are going to discuss about the conservation of linear momentum. Okay, dear students, the next topic we are going to discuss about the conservation of linear momentum. What is that? Conservation of linear momentum. This is the topic. So now we should prove what is the conservation of linear momentum. Before going to prove about the conservation of linear momentum, we should discuss about the definition for linear momentum. Okay, there is no change in the linear momentum of a system of bodies as long as no external force act on it. There is no change in the conservation of the linear momentum of a system of the bodies as long as no external force act on it. This is the definition for conservation of linear momentum. So now we are going to discuss or prove what is that conservation of linear momentum. So here let us consider two objects. Let us consider two objects. This is a object A and this is a object B of mass. This is m1 and this is m2. Velocities, this is u1 and this is u2. Initial velocity. These are the initial velocity. Let us consider two objects A and B of masses m1 and m2, velocity u1 and u2. So the two objects moving in a straight line. So in the beginning we should set or arrange the velocity u1 is greater than u2. Okay. So after time t, the two objects undergoes for the collisions. Okay. So the same object A and this is object B. So what is that? Object A and the second one is object B undergoes for the collision. So while the two objects undergoes for the collision, there is no change in the mass m1 and m2. So now the object F1, this object m1, the object A exert the force on B while undergoes for the collision. So how much force object A exert on B? Fa force object A exert on B. According to the Newton's third law of motion, every action there is an equal and opposite reaction. Is there a yes or no? According by that. So while the object A exert the force Fa on B, at the same time the object B also what is that same amount of force exert on A. So that force we said to be what is that? Fb force. Okay. So how much time? What is the time interval for undergoes for the collision this system? Time t. What is that? Time t time the two objects undergoes for the collision. After the collision, the two objects again start to travel in a straight line. So the object A, this is the object. The first one is this object A and this is object B. There is no change in the mass, but the changes in the velocities. Okay, this is the velocity after the collision. Velocity will be changes. The velocity we are saying final velocity. This is the v1 and this is the v2. This is object A and this is the object B. Okay. Now what here two laws we should apply. The first one is Newton's second law and the second one is Newton's third law. These two things we have to be applied here. The object A exert the force on object B. That is, now what force? The object A exert the force on B, that is Fa, equal to the object A exert the force on B of mass according to the Newton's second law of motion. The rate of change of momentum is directly proportional to applied unbalanced force. Okay, so what is the rate of change of momentum? M of B minus U divided by T should come here. Okay, so what is the, see the object, first object acting the force on object, second object. So here what should we consider? The mass of the second object, which means M2, velocity of second object B2, U2 divided by T. T is common. Next, the object B exert the force on A, that is FB equal to the mass of the first object or mass of the object A, M1 of V1 minus U1 divided by T will come. Okay, so these are the things now we have to be written according by the Newton's second law of motion. Now we are going to apply the Newton's third law of motion. Okay, so by third law of motion, Newton's third law of motion, already told you, for every action there is an equal and opposite reaction. So here the object A exert the force on B, that is we said to be action. So what force object A exert on B? That FA, this is said to be action. So FA equal to reaction. The object B exert the force on object A, that is reaction. So this is FB. So reaction, whenever we are using the, what is that word reaction, so we should add one sign, that is the negative. The negative minus sign indicates reaction. Okay, so FA equal to minus FB. So now take these values, substitute in the formula. So already we found here the values for FA. So what is the value of FA? So M2 V2 minus U2 divided by T equal to, what is the value for FB? M1 of V1 minus U1 divided by T should come. So what is the common here? T is common. So T get cancelled. Okay. Now take these values, write separately. M2 of V2 minus U2 U2 equal to minus M1 of V1 minus U1 will come. Okay. Now multiply these values, M2 with these inside values and M1 with these values. So M2 into V2 minus M2 into U2 will come. Okay. Again, so take this value, substitute inside. So minus M1 V1, again the minus into minus, what will be getting here? Plus. So plus M1 U1 will come. Okay. Now we should arrange these values. See here M2 V2 is there. So here minus M1 V1 is there. These minus M1 V1, if it is comes from right hand side to left hand side, what will be getting this sign? Minus 2, it is changes from minus to plus. So M1 V1 plus M2 V2 equal to, here what value is there? Right hand side M1 U1. So that value itself write down here M1 U1. So here minus M2 U2 is there. This minus M2 U2, if it is what is that, goes from left hand side to right hand side, so it is converted from minus to plus. So plus M2 U2 will come. So now arrange these values. M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. So this is the final derivation for this conservation of linear momentum. So according by this, what is that formula? It is saying total momentum before collision equal to total momentum after collision. Now conservation of linear momentum is proved. So M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. So far we have discussed about Newton's second law of motion statement and its what is that proof and impulse and some examples for impulse and Newton's third law of motion, its examples and conservation of linear momentum statement and its proof. Okay, dear students. So whenever you are getting the chance, prepare very well. Nice to see you through these online videos.